Worksheet number 7, specific heat capacity. Um, for this chapter, what you need to know is the formula QMCAT, and the other thing you need to know is the internal energy is the sum of work and Q, and you also have to know how to find the sign of each both work and Q and heat. Okay, so when you're reading the question, you have to know, is it a positive heat or is it a negative heat? Is it a positive work? Is it a negative work? You have to find that. So you have to know these three, and you can solve the problems in this chapter. Well, for this week, let's say, because we have more things coming next week. Okay, so going through the first question, the temperature of an object increases by 29 degrees. So it says the temperature increases by 29. So that's a change in the temperature. So it's delta T. And since it says increases, so it's a positive delta T. So the delta T should be plus 29. You have to pay attention to these. So I always write a summary of the given information so we can solve it easier. So I write down the information. The delta T is 29. When it absorbs, so it absorbs the heat. So the Q is positive. So the Q is plus 3693 joules. And it wants to calculate. It wants us to calculate the specific heat capacity of the object if the object weighs 331. So we have the mass, we have the Q, and we have delta T. We are trying to solve it for C or C sub S. They show it with both of them, and that's the specific heat capacity. So we have Q equal MCAT, and we're trying to solve it for C, so Q over M delta T. And we have all the information. You put the information in the equation, and you have to double check the units match up, and you don't need any conversion, so the rest is just put these numbers and you find the answer with the unit joule over gram per degree Celsius. The second question, so you read the question, you write down the information. Okay, so we have the mass 80 gram, so we write down the mass. That mass of sample of gas was heated from 25 to 225. So T1, the initial temperature is 25 and the final temperature is 225. So you can label it as T1 and T2, or Ti as T initial and Tf as T final. It doesn't matter, both of them should be fine. You just have to know what is initial and what is final, because that is important for getting the delta, because delta is always T2 minus T1 or Tf minus Ti. Okay, so you have the T1 and T2. During the process, 646 joule of work was done by the system. So if the work is done by the system, is it positive or negative? It's a negative work, so the amount is 346, but the sign is negative, so the work is negative 346 joule. And the internal energy increases by 6,315 joule. So it says increases, so it should be a positive change. So delta E is plus 6315 joule. Okay, and it's asking us to find the specific heat capacity of the gas. Okay, to find the specific heat capacity, we need Q, because we know we have to use QMCAT equation. So we need the Q. We have C, we are solving for C. We have M, and we have T1 and T2, so we can find delta T. So we need Q. To find the Q, we have work and we have internal energy. So we have this equation. Delta E is the sum of work and Q. So to solve this for Q, Q is delta E minus work. So we have the delta E minus the work. So you have to be careful with that. We have a negative sign. It's a subtraction in the formula, and the work is negative, so be careful with that. So adding these two make it a plus sign. So you add these two, and then the Q is plus 6661 joule. So when you find the Q, you can put it in the QMCAT formula, solve it for C, it's Q over M delta T, and you can put the numbers, check the units, and you get the C with a unit of joule over gram over degrees Celsius. Okay, question 3. Um, the specific heat is given, so you write down information. C is 0.385, and pay attention to the unit is joule over gram over degrees Celsius. So if this mass of copper, 153.4 gram of copper, so write down the mass, M 153.4 gram. Initially at 25, so it says initially is Ti or T1 at 21 degrees Celsius. Absorb, so it's absorb, it's gaining the energy, so it's a plus sign. So Q is 1.289 kilojoule. So pay attention to the units. Kilojoule. What will be the final temperature of the copper? Okay, so if you look at the summary of the information, you have C, you have M, you have T1, and you have Q. Okay, even if, so that's why I say write a summary of the information. Even if I don't have the wording of the question, if I see these values, I know I have to use MCAT, QMCAT, right? Because you have Q, you have M, you have C, and you have T1. So what we don't have is the final temperature, and that's what the question is asking for. So the final temperature is TF or T2. That's the thing that we are trying to find. So we use the QMCAT and we solve it for delta T. So it's Q over MC. And so the C is joule over gram per degree Celsius, but the Q is in kilojoule. We cannot use different units. They should be both in the same unit. So we have to convert the Q into joule. So we do the conversion and we get our Q in joule. Then we can plug that number into our formula, our equation. So we put it there in joules, and then you see the units cancel out and we end up with degrees Celsius. So by this you find delta T. It's not done yet. That's a common mistake you might do in the exam. So you find the delta T, it's not done. The question is asking for the final temperature, not the change of temperature. So you find delta T, and you have the initial temperature. So delta T is T2 minus T1 or TF minus TI. And solve it for T2, it's delta T plus T1. So you have the delta T, you just find it from this equation from here. And T1 is given the information, you have it here, it's 21 degrees Celsius. So you add these two, and T2 is 42.8 degrees Celsius. Okay, as you can see, it's just using this equation. It's not anything hard. You just have to practice using it. So the last question, the specific heat capacity of methane gas is 2.2 joule per gram per degree Celsius. So you write it down, you write a summary of the given information. So C is 2.2. How many joules of heat are needed to raise the temperature of 5 grams? So it's asking for the Q in joules, so you write Q as what's wanted. And we have the mass, so you write down the mass, it's 5 gram. And the temperature going from 22 to 57. So T1 is 22 and T2 is 57. Okay, so you need the Q, you're using the MCAT formula. So 5 gram times the C, and you see the units are canceling out, so that's good. So you just put these numbers in the MCAT formula and you find the Q in joules.